Hello, and welcome to the Restful Stories. We invite you to journey with us into the green heart of our world, a realm brimming with secrets and ancient life. We are always exploring fascinating new topics, so if you enjoy these kinds of stories, be sure to subscribe to the channel to be notified when future tales are released. Tonight, we enter a world where the air is thick with the scent of damp earth and the constant hum of existence. These are the great rainforests, the oldest and most complex ecosystems on Earth. They are places of staggering beauty and bewildering variety. Yet they are also realms of paradox and profound importance, influencing the very climate of our planet and the water that sustains us. Their story is the story of life itself, written over millions of years in a language of leaves, roots, and rain. Join us as we travel from the vast, sun-drenched canopy to the mysterious twilight of the forest floor, uncovering the intricate connections and remarkable adaptations that make these worlds so vital. Our journey begins not on the ground, looking up, but far above, with a view of our planet as a single, living sphere. Imagine our planet viewed from space, a swirling blue, marble laced with the white of clouds and the brown and green of land. From this distance, the great forests of the world appear as deep green swaths, vital organs, breathing life into the atmosphere. Among these, the rainforests stand apart, yet they occupy a surprisingly small portion of the Earth's total surface, less than 3% in fact. This seemingly modest footprint is profoundly deceiving, for within this tiny fraction of our world's geography lies a biological treasure of almost unimaginable proportions. These forests are the most vibrant and concentrated pockets of life on the planet, cradling more than half of all the world's terrestrial animal species. This is a staggering concentration of existence, a biological metropolis humming with a diversity that dwarfs nearly every other ecosystem combined. To walk into a rainforest is to enter a world where the very air is thick with the processes of life and death, where every leaf, every patch of soil, and every drop of water is teeming with creatures great and small, from the iridescent flash of a hummingbird's wing to the silent, slow work of fungi on the forest floor. At the heart of this verdant kingdom lies the undisputed sovereign, the Amazon rainforest, known in many South American languages as the selva. It is a basin of such immense scale that it defies easy comprehension. It unfurls across roughly 40% of the entire South American continent, a colossal expanse of green that stretches from the Andes Mountains in the west to the Atlantic Ocean in the east. This single forest is so vast that if it were to declare its own sovereignty, it would rank as the 9th largest nation on Earth, eclipsing countries like Argentina and Kazakhstan in sheer area. Its borders are not political but ecological, weaving through 9 different nations, with the lion's share, about 60%, lying within Brazil. Its influence is continental, shaping weather patterns and hydrological cycles that extend far beyond its leafy boundaries. This is not merely a collection of trees. It is a world unto itself. The lifeblood of this immense ecosystem is a river that matches the forest in its epic proportions, the Amazon River. While other rivers may claim greater length, none can challenge the Amazon's supremacy in volume. It is, by a staggering margin, the largest river in the world. Every second, it pours an average of 200,000 cubic meters, or over 7 million cubic feet, of fresh water into the Atlantic Ocean. This discharge is greater than the next 7 largest rivers combined. The sheer force of this freshwater torrent pushes the salt water of the ocean back for more than 160 kilometers, or about 100 miles, creating a vast lens of drinkable water that early sailors could find long before they ever saw the South American coast. It is a river that builds its own delta and shapes the ocean itself. But the Amazon is not the only giant. Thousands of miles away, cradled in the heart of Africa, lies the world's second largest rainforest, the Congo Basin. This magnificent forest, nourished by the mighty Congo River, spans across 6 Central African countries and represents a vital storehouse of biodiversity, home to iconic species such as forest elephants, gorillas, and bonobos. Together, the Amazon and the Congo represent the 2 great green lungs of the equatorial world. These incredible ecosystems are not recent creations. They are ancient realms, the Earth's oldest living ecosystems. Their story stretches back into deep time, to an era when the continents were still drifting toward their current positions. Some of these forests have survived for at least 70 million years, making them living relics from the age that dawned after the dinosaurs vanished. They weathered the cataclysm that ended the Cretaceous period and have endured ice ages and dramatic shifts in global climate. This immense longevity, this unbroken thread of existence stretching across geological epochs, is the secret to their astonishing complexity. Millions of years of relative stability provided the evolutionary stage upon which the intricate dance of coevolution could play out, fostering an explosion of species that specialized to fill every conceivable niche. The result is a density of life found nowhere else. In a temperate forest in Europe or North America, one might find a dozen, perhaps 24 different tree species in a given area. But in the rainforest, a single hectare, an area measuring 100 meters by 100 meters, which is roughly 2.5 acres, can harbor more than 480 distinct species of trees. This is not just variety. It is a hyperdiversity that creates a complex, interwoven architecture of roots, trunks, and crowns. Scaling this incredible density up to the entirety of the Amazon gives us a number that is difficult to process: an estimated 390 billion individual trees. It is a forest of staggering numbers, a living library of genetic information encoded in a multitude of forms. To truly grasp the environment these trees create, one must imagine the journey of a single drop of water. When the rain begins to fall, it does not immediately splash onto the ground. Instead, it first strikes the uppermost layer of the forest, the emergent layer, where the tallest trees, some reaching 60 meters or nearly 200 feet into the sky, break through the main ceiling of the forest. From a leaf here, the water may drip down to the next level, the dense, interlocking canopy, a world of its own where much of the rainforest's life is concentrated. This leafy roof is so thick that the journey downwards slows to a crawl. The raindrop might slide down a vine, pool in the cup of a bromeliad, or be deflected by the wing of a passing macaw. It continues its descent through the darker, more humid understory, a realm of shorter trees and shrubs adapted to the low light. This entire process, this slow, deliberate percolation from the sun-drenched canopy to the shadowed earth, can take as long as 10 minutes. This extended journey illustrates the forest's profound ability to capture and regulate the flow of water, creating its own humid microclimate and ensuring that the life-giving moisture is gently and evenly distributed to the roots below. The sheer density of this canopy, which so effectively slows the journey of water, has another profound consequence. It creates a world of deep and perpetual twilight on the forest floor. Only about 2% of the sunlight that bathes the upper reaches of the forest ever manages to filter down to the ground. This creates a starkly stratified environment, a vertical world of distinct light zones. While the forest floor is a place of shadows, the canopy above is a powerhouse of solar energy conversion. This vast, elevated sea of leaves functions as a single, continent-sized biological machine, tirelessly engaging in photosynthesis. In this fundamental process of life, the trees inhale the carbon dioxide we exhale, and, using the energy of the sun, transform it into the woody tissue of their trunks and branches, releasing pure oxygen as a byproduct. The collective output of this green engine is staggering. The Amazon rainforest alone is credited with producing roughly 20% of the oxygen in our planet's atmosphere, a constant, life-sustaining exhalation that has earned it the well-deserved title of the lungs of the planet. The deep shade cast by this productive canopy has, over millions of years, driven the evolution of a unique community of plants adapted to a low-light existence. Many of these specialists have become familiar companions in our own homes. When we admire the broad, heart-shaped leaves of a Swiss cheese plant, the vibrant, water-holding cups of a bromeliad, or the delicate, painted leaves of a calathea, we are looking at living descendants of the rainforest understory. These common houseplants are biological emissaries from that world of filtered sunbeams, their entire physiology geared towards capturing the scarce photons that trickle down from the bright world above. Their success in our homes is a testament to their adaptation to the stable temperatures and high humidity that characterize the forest floor, conditions we often unknowingly replicate in our indoor environments. They are a tangible, living link to the immense and distant forests from which they came. While the Amazon often commands the spotlight, this intricate vertical structure of life is a defining feature of all the world's great tropical forests. Thousands of kilometers away, in the heart of Africa, lies the second largest rainforest on Earth, the Congo Basin. This vast wilderness, sprawling across 6 nations, is a world of breathtaking biodiversity in its own right, home to iconic species such as forest elephants, lowland gorillas, and our closest living relatives, the chimpanzees and bonobos. Its ecological significance is on a par with the Amazon, a vital reservoir of life and a crucial regulator of regional and global climate. Yet the very concept of a rainforest is not confined to the heat and humidity of the tropics. There is another, less familiar type, the temperate rainforest. These remarkable ecosystems are found in the cooler, middle latitudes of our planet, typically in coastal regions that receive immense amounts of rainfall. They may not possess the sheer species count of their tropical counterparts, but they often boast a greater biomass, a world of colossal trees and deep, verdant carpets of moss. A spectacular example of this cooler, wetter world is the Valdivian temperate rainforest, a narrow strip of forest clinging to the Pacific coast of southern Chile. It is one of the 5 largest rainforests on the planet, a realm of ancient trees, dense bamboo thickets, and an astonishing abundance of ferns and mosses that drape every available surface in a cloak of green. This is a mist-shrouded, mystical environment, home to unique creatures like the pudu, which stands only about 30 centimeters, or roughly 1 foot, high at the shoulder, making it the world's smallest deer. Whether tropical or temperate, these ecosystems are fundamentally defined by their relationship with water, and they, in turn, are critical guardians of the Earth's freshwater supply. They act as immense natural sponges, absorbing torrential downpours, which prevents soil erosion and catastrophic flooding. The water is then filtered through the complex web of roots and soil and released slowly and cleanly into rivers and underground aquifers. This service is performed on an almost unimaginable scale in the Amazon basin. The sheer volume of water cycling through this system is so vast that it is estimated to account for approximately 20% of all the fresh water that flows across the continents into the world's oceans. This profound ecological role is complemented by the direct gifts these forests have bestowed upon humanity, particularly in the realm of food. Many of our most cherished flavors and staple foods originated as wild plants in the rainforest. The journey of chocolate from a bitter seed to a sweet delicacy begins with the cacao tree, a native of the Amazonian understory. The ubiquitous banana, the world's most popular fruit, first grew in the rainforests of Southeast Asia. The rich, aromatic beans that give us coffee were first discovered in the highland forests of Ethiopia, while the sweet, tangy pineapple is another native of the South American rainforest. These foods are not mere novelties. They are the foundation of global agricultural industries, a daily reminder of our deep and ongoing dependence on the biological wealth of these distant ecosystems. But the edible plants we have cultivated represent only a tiny fraction of the life that thrives there. To truly grasp the scale of rainforest biodiversity, one must consider the insects. The Amazon is a world buzzing with an almost incomprehensible variety of them, with current estimates suggesting it is home to some 2.5 million distinct insect species. This is a universe of intricate relationships, of pollinators perfectly matched to their flowers, of camouflaged predators and brilliantly colored butterflies, all forming the foundational layers of the food web. At the top of this intricate web are the large, iconic animals whose fates have become symbols of the rainforest's vulnerability. In the dwindling forests of Asia, the majestic tiger, the powerful Sumatran rhinoceros, and the intelligent arboreal orangutan all face the threat of extinction. Similarly, in the mountain rainforests of Central Africa, the gentle mountain gorilla, one of our closest relatives, struggles to survive in its diminishing habitat. The precarious existence of these magnificent creatures underscores the urgent and profound threats facing their ancient forest homes. The ongoing struggle for survival faced by these well-known, charismatic species serves as a poignant reminder of the fragility of these ecosystems, yet they represent only the most visible fraction of the life that is at risk. The rainforests are a frontier of biological discovery, a place where the catalog of life is still being written. Even today, in the 21st century, scientists continue to find new species of plants and animals hidden away in the unexplored vastness of the forest. A new species of monkey, a previously unknown type of frog with translucent skin, a flower with a bizarre and intricate structure. These discoveries are still a regular occurrence, hinting at the immense biological richness that remains unknown to science. Each of these new species is a unique evolutionary solution, a living library of genetic information that has evolved over millions of years. When a section of rainforest is destroyed, we are not just losing trees. We are losing a potential source of new medicines, new materials, and a deeper understanding of the processes of life itself. We are, in a very real sense, burning a library before we have had a chance to read its books. This library of life has its own unique global distribution. While the Amazon and the Congo dominate in terms of sheer size. The island of New Guinea, located just north of Australia, holds the distinction of being the world's third largest contiguous rainforest. This massive island, politically divided between the nation of Papua New Guinea and the Indonesian provinces of Papua and West Papua, is a land of incredible geographical and biological diversity. Its rainforests stretch from steamy, mangrove-lined coasts up to cool, cloud-shrouded mountain peaks. This rugged and varied terrain has fostered an explosion of unique species found nowhere else on Earth, including the spectacular birds of paradise, with their elaborate plumage and intricate courtship dances, and a bewildering array of tree kangaroos, marsupials that have adapted to a life in the canopy. The human cultural diversity of New Guinea is just as remarkable, with over 1,000 distinct languages spoken on the island, a testament to the isolating effect of its dense forests and mountainous landscape. Yet, this world of incredible diversity, both biological and cultural, is vanishing at a terrifying rate. The relentless pressure of deforestation, driven by a global demand for timber, agricultural land, and mineral resources, is consuming the world's rainforests at an unsustainable pace. The scale of this destruction is difficult to fully comprehend, but one stark statistic helps to put it into perspective. Every single minute, an area of rainforest equivalent to the size of 40 football fields is lost. This is not a slow, creeping decline. It is a rapid, systematic dismantling of the world's most complex ecosystems. While you have been listening to these words, hundreds of acres of ancient forest have been felled, burned, and converted to other uses. This relentless destruction is mirrored in other, remote and vital rainforest regions. In the heart of Southeast Asia lies the Borneo lowland forest, another of the world's top 5 largest rainforests. This ancient island ecosystem, shared between Indonesia, Malaysia, and Brunei, is the only place on Earth where orangutans, proboscis monkeys, and pygmy elephants coexist. It is a world of towering dipterocarp trees, a family of giants that form the backbone of the Asian rainforest canopy. And it, too, is under siege from the expansion of palm oil plantations and illegal logging operations. The loss of these specific, iconic forests is part of a much larger, global pattern. Across the tropics, these vibrant ecosystems are being systematically eroded. The sheer concentration of life within them means that this destruction has a disproportionately large impact on global biodiversity. More than half of all the world's known plant species are found exclusively in rainforests. This botanical treasure trove includes not only the towering trees that form the canopy, but also a vast understory of shrubs, herbs, vines, and epiphytes, plants that grow on other plants. Many of these species have yet to be studied for their potential medicinal properties or other uses. The rich chemical diversity that allows them to thrive in a competitive and predator-filled environment is a resource of incalculable value. This botanical wealth is not evenly distributed across the globe. Some nations have been blessed with a disproportionate share of this natural heritage. Brazil, by virtue of encompassing the majority of the Amazon, has by far the largest area of rainforest cover of any country on Earth. Its fate is inextricably linked to the fate of the Amazon, and the policies enacted in its capital, Brasilia, have a direct and profound impact on the health of the entire planet. Following Brazil in this ranking is the Democratic Republic of Congo, home to the largest portion of the Congo Basin rainforest. This vast Central African nation holds a forest heritage of immense global importance, but it has been plagued by decades of conflict and political instability, which has made conservation efforts incredibly challenging. The third nation in this triumvirate of rainforest giants is Indonesia, an archipelago of over 17,000 islands that straddles the equator. Its rainforests, spread across islands like Sumatra, Borneo, and New Guinea, are some of the most biodiverse on the planet. Together, these three countries, Brazil, the Democratic Republic of Congo, and Indonesia, are the custodians of the world's three largest rainforest areas. They hold the keys to the future of these vital ecosystems, and the choices they make in the coming years will have consequences that reverberate across the globe for centuries to come. The biological richness of these forests is not uniformly spread from the ground to the sky. It is, to a large extent, concentrated upwards. A significant percentage of all life in the rainforest is found not on the dark forest floor, but high up in the trees, in the sun-drenched world of the canopy. This elevated ecosystem, often more than 30 meters, or about 100 feet above the ground, is a world of its own, with a unique climate and a specialized community of plants and animals. This arboreal, or tree-dwelling, lifestyle has driven some remarkable evolutionary adaptations. Life in the canopy has its own set of challenges and opportunities, and countless species have evolved to master it. This has led to a fascinating pattern of convergent evolution, where animals from completely different evolutionary backgrounds have independently developed similar solutions for a life lived off the ground. For example, while anteaters are typically associated with foraging on the ground, the rainforest is home to species like the silky anteater, a small, nocturnal creature with a prehensile tail that it uses as a fifth limb to securely grip branches while it searches for insects. Similarly, while we might think of salamanders as creatures of damp leaf litter and forest streams, the rainforest canopy is home to species of lungless salamanders that spend their entire lives high in the trees, absorbing oxygen directly through their skin in the moist, epiphyte-laden environment. This move into the third dimension of the forest has been a powerful evolutionary driver, creating a world where the normal rules of ground-dwelling life are suspended, and a whole new set of adaptations has come to the fore. The intricate, multi-layered structure of the rainforest, from the sunlit canopy to the shadowed floor, is not just a stage for this drama of evolution. It is an active participant in shaping the very climate of our planet. These forests are vast, living engines that help regulate global temperatures and stabilize weather patterns. The dense canopy acts as a giant, dark green blanket over the equatorial regions of the Earth, absorbing a significant amount of solar radiation that would otherwise be reflected back into the atmosphere. This absorption helps to cool the planet. At the same time, the massive amount of water vapor released by the trees through transpiration fuels the formation of clouds. These clouds, in turn, reflect incoming sunlight, further contributing to a cooling effect. This intricate dance between trees, water, and sunlight is a powerful force for climatic stability, influencing everything from the strength of global wind currents to the distribution of rainfall far beyond the tropics. The rainforests are not passive features of the landscape. They are dynamic systems that actively create the conditions that allow them and countless other species to thrive. This self-perpetuating system, however, is being dangerously undermined by human activity. The primary threat to the rainforests, the driving force behind their rapid destruction, is deforestation. The latest estimates suggest that about 17% of the original Amazon forest has already been lost, an area larger than the country of France. This figure represents a staggering loss of biodiversity and a significant blow to the planet's climate regulation system. When the forest is cleared, this vital function is reversed. Instead of absorbing carbon dioxide, the burning of the forest releases vast quantities of it into the atmosphere, transforming a vital carbon sink into a major source of greenhouse gas emissions. The removal of the forest canopy also disrupts the local water cycle. The process of transpiration, where a single large tree can lift over 400 liters, or about 100 gallons, of water from the soil and release it into the atmosphere each day, is the engine of the rainforest's self-watering system. This massive, invisible river of water vapor rising from the forest is what generates the region's famously heavy rainfall. When the trees are cut down, this engine is shut off. The air becomes drier, rainfall decreases, and the remaining forest becomes more susceptible to fire. This creates a dangerous feedback loop, where deforestation leads to drought, and drought makes the forest more vulnerable to further destruction. This connection is not just theoretical. It has been observed in regions where large-scale deforestation has occurred, leading to prolonged dry seasons and a measurable decline in local precipitation. The consequences of this disruption extend far beyond the immediate vicinity of the cleared land, affecting agricultural productivity and water security for millions of people. The human cost of this destruction is immense and multifaceted. It is estimated that 1.6 billion people worldwide depend directly on forests for their livelihoods. This includes not only the indigenous communities who have lived in and stewarded these forests for millennia, but also countless other rural populations who rely on the forest for food, fuel, medicine, and building materials. For these people, the forest is not a distant wilderness. It is their home, their pharmacy, and their supermarket. The value of the rainforest's pharmacy, in particular, is something that benefits all of humanity. More than 60% of all anti-cancer drugs in use today have their origins in natural sources, with a significant number derived from plants, fungi, and bacteria found in rainforests. The rosy periwinkle, a small, unassuming flowering plant native to the rainforests of Madagascar, yielded the powerful chemotherapy drugs vincristine and vinblastine, which have dramatically increased survival rates for childhood leukemia and Hodgkin's lymphoma. This is just one of thousands of examples. The rainforest is a vast, living chemical laboratory where plants have spent millions of years evolving complex compounds to defend themselves from insects and diseases. Many of these same compounds have proven to be remarkably effective at fighting human diseases. The potential for new discoveries is enormous, but with every hectare of forest that is lost, we risk losing the next breakthrough cure before we even know it exists. One of the most historically significant medicinal discoveries from the rainforest is the story of quinine. For centuries, malaria was one of the most deadly diseases on the planet, claiming millions of lives. The first effective treatment came from the bark of the cinchona tree, a native of the Andean rainforests of South America. Indigenous peoples of the region had long known of the bark's fever-reducing properties. In the 17th century, Jesuit missionaries learned of this traditional remedy and introduced it to Europe, where it became the first line of defense against malaria for over 300 years. The active ingredient, quinine, was eventually isolated and synthesized, but its discovery is a powerful testament to the value of both biodiversity and the traditional ecological knowledge held by indigenous communities. The wonders of the rainforest are not limited to its flora. On the small Caribbean island of Dominica, nestled within a lush, mountainous rainforest, lies a truly remarkable geological feature, a boiling lake. This flooded fumarole, a crack in the Earth's crust, is heated by molten magma deep below. The water temperature along the edges of the lake hovers between 82 and 92 degrees Celsius, or about 180 to 197 degrees Fahrenheit. But the center is too hot to measure, a constantly roiling cauldron of superheated grayish-blue water enveloped in a cloud of vapor. It is a raw and powerful display of the geothermal forces that lie just beneath the Earth's surface, a stark contrast to the cool, green tranquility of the surrounding forest. This primal landscape is a reminder that the rainforest is a world of extremes, a place of both gentle life-giving rain, and powerful elemental forces. This richness and diversity extend to the flavors that have shaped our culinary world. The warm, aromatic spice we know as cinnamon is derived from the inner bark of several tree species belonging to the genus Cinnamomum, native to the rainforests of Southeast Asia. Similarly, the sweet, complex flavor of vanilla, the world's most popular flavoring, comes from the cured seed pods of the vanilla orchid, a vining plant that originally grew in the Mesoamerican rainforests and was first cultivated by the Totonac people of what is now Mexico. These spices, which we now take for granted, were once rare and precious commodities, driving global trade and exploration. They are a direct, flavorful link to the distant tropical forests from which they came, a small taste of the incredible chemical and biological diversity that these ecosystems hold. The rich tapestry of life within the rainforest extends far beneath the surface of its rivers and streams. The Amazon basin is not just a hydrological marvel in terms of its water volume. It is an aquatic ecosystem of almost unparalleled diversity. It is home to an estimated 3,000 species of freshwater fish, more than are found in the entire Atlantic Ocean. This is a staggering number, representing roughly 10% of all known fish species on Earth. This underwater world is as varied and complex as the forest that surrounds it. It is a realm of giants, like the arapaima, one of the world's largest freshwater fish, which can grow to over 3 meters, or nearly 10 feet, in length, and has the remarkable ability to breathe air. It is also a world of fearsome predators, like the black caiman and the infamous piranha, whose reputations, though often exaggerated, are rooted in their efficiency as hunters. But it is also a world of dazzling color, with hundreds of species of smaller tetras and cichlids that are the ancestors of many of the most popular aquarium fish. This aquatic diversity is a crucial source of protein for the millions of people who live along the river's banks. And it is a vital, though often overlooked, component of the rainforest's overall biodiversity. Above the water, the air is filled with the calls and colors of an equally impressive avian community. The Amazon is home to over 1,300 species of birds, a riot of feathers and song that makes it one of the most important centers of bird diversity on the planet. This includes the iconic macaws, with their brilliant plumage and raucous calls, the aptly named toucans, whose enormous, colorful bills are surprisingly lightweight, and a bewildering array of hummingbirds, antbirds, and flycatchers, each adapted to a specific niche within the forest's complex architecture. The sheer number of bird species is a direct reflection of the forest's structural complexity and botanical richness, which provides an incredible variety of food sources, from fruits and nectar to insects and other small animals. This avian abundance is matched by the diversity of mammals that roam the forest floor and navigate the canopy. The Amazon is home to more than 400 species of mammals, a group that includes the elusive jaguar, the largest cat in the Americas, the gentle, slow-moving sloth, and a remarkable number of primate species, from the tiny pygmy marmoset to the loud and territorial howler monkey. This pattern of high biodiversity is not exclusive to the tropics. Even the temperate rainforests, with their cooler climates, boast unique and fascinating ecosystems. These misty, verdant worlds are found in scattered locations around the globe, from the Pacific Northwest of North America, with its towering Douglas firs and Sitka spruces, to the wind-swept coasts of New Zealand, home to unique, flightless birds and ancient tree ferns. The island of New Guinea, straddling the equator and the Pacific, is another global hotspot for rainforests. Its immense size and rugged, mountainous terrain have created a mosaic of different forest types, from coastal mangrove swamps to alpine cloud forests. This geographical isolation and variety have made New Guinea a powerhouse of evolution, and it is home to a significant portion of the world's total rainforest area and an even larger fraction of its biodiversity, much of which is still being discovered and documented. Yet, even as we continue to catalog the wonders of these ecosystems, their future hangs in a precarious balance. A groundbreaking study published in the year 2017 delivered a shocking verdict on the state of the world's tropical forests. For decades, we have relied on these forests to act as a crucial carbon sink, absorbing more carbon dioxide from the atmosphere than they release. However, this study revealed that, due to widespread deforestation and degradation, tropical forests as a whole have now become a net source of carbon emissions. The amount of carbon released from burning, logging, and the decay of dead trees now outweighs the amount absorbed by living, growing forests. This is a dangerous tipping point, a sign that we are fundamentally altering the role these ecosystems play in the Earth's climate system. We have transformed our greatest natural ally in the fight against climate change into an adversary. The human dimension of this crisis is equally profound. 1 out of every 4 people on this planet relies directly on forest resources for their livelihood. This figure, encompassing some 2 billion individuals, highlights the deep and intimate connection between human well-being and the health of our forests. For these communities, the forest provides not just income, but also food security, clean water, and cultural identity. The destruction of the forest is not an abstract environmental problem. It is a direct threat to their survival and way of life. Recognizing this interconnectedness between environmental health and human prosperity is at the heart of the modern conservation movement. Organizations like the Rainforest Alliance were founded on the principle that the best way to combat deforestation is to make it economically viable for people to protect their forests. They work to promote sustainable agriculture and forestry practices, creating a marketplace for products that are grown in a way that respects the environment and supports local communities. This approach seeks to transform the economic drivers of destruction into incentives for conservation. The potential impact of these nature-based solutions is enormous. A comprehensive analysis has shown that natural climate solutions, a category that includes the conservation, restoration, and improved management of forests and other ecosystems, could provide more than 1/3 of the global climate mitigation needed by the year 2030 to keep global warming below 2 degrees Celsius. This is a staggering potential, highlighting that protecting and restoring nature is not just a nice-to-have. It is an essential and powerful strategy in addressing the climate crisis. This effort also provides a lifeline for some of the world's most endangered animals. The Javan rhinoceros, with a global population of fewer than 80 individuals, now survives only in a single national park in a rainforest on the western tip of the island of Java. The survival of this species, and countless others like it, is entirely dependent on the successful protection of its last remaining forest habitat. Their fate is a stark barometer of our own success or failure in stewarding the planet's natural heritage. Beyond their crucial role in regulating climate and harboring biodiversity, rainforests perform another vital, life-sustaining service. They are natural water filters. The complex, multi-layered structure of the forest acts as a living purification system. When rain falls, the dense canopy of leaves and branches breaks the force of the downpour, preventing the soil erosion that would otherwise clog rivers and streams with sediment. The water that does reach the ground then percolates slowly through the thick mat of leaf litter and the intricate network of roots that permeates the forest floor. This process naturally filters out impurities and pollutants, ensuring that the water that eventually flows into rivers and recharges underground aquifers is remarkably clean and pure. This ecological service provides clean drinking water for millions of people living downstream from forested areas and maintains the health of aquatic ecosystems that are sensitive to pollution and sedimentation. The very architecture of the forest, the high density of trees that creates the iconic umbrella-like canopy, is the key to this function, regulating the flow of water and safeguarding its quality. This intricate relationship between the forest and the soil beneath it is one of the great paradoxes of the rainforest ecosystem. One might assume that a place that supports such a lush and overwhelming abundance of life must be rooted in incredibly rich and fertile soil. However, in many tropical rainforests, the opposite is true. The soil itself is often surprisingly poor, thin, and nutrient deficient. The key to the rainforest's exuberance lies in the speed and efficiency with which it recycles nutrients. In the hot, humid conditions of the tropics, decomposition happens at a ferocious pace. When a leaf falls, a branch breaks, or an animal dies, a vast army of fungi, bacteria, and insects immediately goes to work, rapidly breaking down the dead organic matter and releasing its vital nutrients. These nutrients are then immediately reabsorbed by the dense mat of shallow roots that crisscross the forest floor. The system is so efficient that very few nutrients ever have a chance to leach down into the deeper soil layers. The majority of the ecosystem's capital, its wealth of nitrogen, phosphorus, and other essential elements, is not locked away in the soil, but is constantly circulating, held within the living biomass of the plants and trees themselves. This reality has profound implications for how these landscapes respond to human intervention. When the forest is cleared and burned, this entire, tightly closed nutrient loop is broken. The nutrients that were held in the vegetation are released in a sudden flash of ash, providing a temporary boost of fertility to the soil. However, without the protective canopy and the absorbent root mat, this newfound fertility is quickly lost. The head tropical rains, which once nourished the forest, now become an agent of degradation, washing the nutrient-rich topsoil away and leaving behind the sterile, unproductive clay that lies beneath. This is why so many areas, cleared from rainforest for agriculture or cattle ranching, can only sustain these activities for a few years before the land becomes exhausted and is abandoned. The forest's appearance of indestructible vitality is, in fact, a fragile illusion, dependent on an ancient and unbroken cycle of life, death, and rapid decay. Understanding the primary drivers of this destruction is crucial to formulating any effective response. The vast majority of rainforest destruction is not driven by some abstract, malevolent force, but by the global economy's relentless demand for commodities. The single largest driver, by a significant margin, is agriculture, particularly the clearing of land for cattle ranching in South America and for the cultivation of cash crops like palm oil and soybeans in Southeast Asia and beyond. These activities are often linked to complex global supply chains, meaning that consumers in Europe and North America can unknowingly contribute to deforestation through the products they buy. This places a profound responsibility on both corporations and consumers to demand greater transparency and sustainability in the sourcing of these commodities. Within this challenging landscape, there is a powerful and often overlooked source of hope and effective stewardship: the indigenous communities who call the rainforest home. For countless generations, these communities have lived in and from the forest, developing deep and sophisticated systems of traditional ecological knowledge. They are not just inhabitants of the forest. They are often its most effective guardians. Numerous studies have shown that on a global scale, the lands managed by indigenous peoples and local communities exhibit significantly lower rates of deforestation and biodiversity loss than lands managed by governments or private entities. This success is rooted in a worldview that sees the forest not as a resource to be extracted, but as a living, interconnected system of which humans are an integral part. This intimate knowledge allows for a form of sustainable use that can maintain the forest's health and integrity over the long term. Recognizing the rights of these communities and empowering them to continue their stewardship is now widely seen as one of the most just and effective strategies for rainforest conservation. The incredible variety of life in the rainforest is matched by the variety of the forests themselves. The term rainforest is not a monolithic category. It encompasses a wide range of different ecosystem types, each with its own unique characteristics, shaped by factors like soil composition, altitude, and seasonal rainfall patterns. For example, there are the flooded forests of the Amazon basin, known as Igapo, which are permanently submerged in blackwater rivers, and the Varzea forests, which are seasonally flooded by nutrient-rich whitewater rivers. There are the montane cloud forests, found high on tropical mountainsides, which are constantly bathed in mist and are draped in an otherworldly abundance of mosses and epiphytes. Each of these forest types supports its own specialized community of plants and animals, making the overall picture of rainforest biodiversity even more complex and fascinating. This diversity of forest types is a key feature of the Sundaland rainforest region, a biological hotspot that includes the Malay Peninsula and the islands of Borneo, Sumatra, and Java. This region, which includes parts of Brunei, Indonesia, Malaysia, and Singapore, is a world of incredible natural wealth. But it has also experienced some of the highest rates of deforestation on the planet in recent decades, primarily driven by the expansion of palm oil and rubber plantations. The scale of this loss is staggering. Globally, an area of tropical forest the size of the nation of Bangladesh is lost every single year. This is a relentless, ongoing hemorrhage of the planet's most vital ecosystems. To put it in more concrete terms, in the single year of 2017, the world lost 15.8 million hectares of tropical forest, an area larger than the country of Greece. This is not a historical problem. It is a current and accelerating crisis. The cumulative impact of this destruction is a scar on the face of the planet. It is estimated that humans have already destroyed nearly half of the world's original forest cover, with the vast majority of this loss occurring in just the last few decades. The verdant belt that once encircled the Earth's equator is now a tattered and fragmented patchwork of what it once was. The immense and biologically rich rainforests of the Sundaland region are just one piece of a larger, globally significant mosaic of tropical ecosystems. To the north and west lies the Indo-Burma rainforest region, another of the planet's most critical biodiversity hotspots. This vast and geographically complex area spans across multiple nations, including Bangladesh, Cambodia, China, India, Laos, Myanmar, Thailand, and Vietnam. It is a land of dramatic topographical diversity, from the towering peaks of the Himalayas to the vast floodplains of the Mekong River. This variety in landscape has given rise to a corresponding variety in forest types, from tropical dry evergreen forests to montane cloud forests. The region is home to an extraordinary number of endemic species, creatures found nowhere else on Earth, including the critically endangered saola, a mysterious, forest-dwelling bovine that was only discovered by science in 1992. The Indo-Burma region is a place of ancient cultures and deep connections between people and the forest. But it is also facing intense pressure from rapid economic development, agricultural expansion, and the construction of large-scale infrastructure projects like dams and roads, which fragment the remaining forest habitats. Traveling west across the globe, we find another vital corridor of tropical biodiversity in the Mesoamerica rainforest region. This isthmus of land, connecting North and South America, includes parts of Belize, Costa Rica, El Salvador, Guatemala, Honduras, Mexico, Nicaragua, and Panama. While smaller in overall area than the Great Basins of the Amazon or the Congo, this region serves as a crucial biological bridge, allowing for the interchange of species between the two continents. It is a land of active volcanoes, vibrant coral reefs, and dense rainforests that are home to a unique blend of fauna, including iconic species like the resplendent quetzal, the jaguar, and the Baird's tapir. Costa Rica, in particular, has become a global model for conservation, having successfully reversed decades of deforestation and placed over a quarter of its land area under protection in national parks and reserves, demonstrating that a commitment to environmental stewardship can coexist with and even drive economic development through ecotourism. South of this bridge, on the Atlantic coast of South America, lies a distinct and highly endangered rainforest region known as the Atlantic Forest, or Mata Atlantica, originally stretching along the coast of Brazil and into parts of Paraguay and Argentina. This forest is geographically separate from the much larger Amazon basin to the west. Over millions of years of isolation, it has evolved its own unique and spectacular array of species, with an incredibly high rate of endemism. Sadly, the Atlantic forest has also been at the epicenter of human settlement and development for over 500 years. The vast majority of Brazil's population and its largest cities are located within the historical footprint of this forest. As a result, it has been catastrophically deforested, with less than 10% of its original extent remaining. These surviving fragments, often small and isolated, are now the last refuge for a host of critically endangered species, including the golden lion tamarin, a small, brilliantly colored monkey that has become a symbol of the desperate fight to save this ravaged ecosystem. Further to the west, nestled along the Pacific coast of South America, is the Choco rainforest region, stretching from southern Panama through Colombia and into northern Ecuador. This is one of the wettest places on the entire planet. The constant moisture from the Pacific Ocean, trapped by the rising Andes Mountains, results in staggering annual rainfall totals, in some places exceeding 10,000 millimeters, or nearly 400 inches per year. This hyper-humid environment has fostered an explosion of life, particularly among amphibians and reptiles, making it a global hotspot for these groups. The Choco is a land of superlatives, a place of intense biological activity and remarkable evolutionary novelty. It is a world that is still revealing its secrets, with new species being discovered on a regular basis. The richness of this region is not limited to its animals. In a single national park in the rainforest of Peru, on the eastern slopes of the Andes, researchers have documented over 1,300 distinct species of butterflies. To put this number in perspective, the entire continent of Europe is home to fewer than 400 butterfly species. This single park in Peru, a tiny dot on the world map, harbors more than 3 times the butterfly diversity of a landmass that stretches from the Arctic Circle to the Mediterranean Sea. This incredible concentration of life is a hallmark of the tropical rainforest, a testament to the sheer creative power of evolution when given millions of years of relative stability and a warm, wet climate. This adaptive radiation is not confined to the most well-known groups of animals. The rainforest canopy is a world that has been colonized by creatures we normally associate with entirely different environments. For example, there are species of crabs that have adapted to a fully arboreal life. These tree-climbing crabs spend their entire lives high in the canopy, finding everything they need in the water that collects in the hollows of trees and the cups of bromeliad plants. They are a vivid example of how life in the rainforest finds a way to exploit every available niche, pushing the boundaries of what we thought was possible for a particular group of animals. The rainforest has also been a source of materials that have fundamentally shaped human civilization. 2 of the most important of these are rubber and bamboo. The story of rubber begins in the Amazon, where indigenous peoples had long used the milky latex of the Hevea brasiliensis tree for a variety of purposes. In the mid-19th century, the discovery of vulcanization by Charles Goodyear transformed this curious, natural polymer into an essential industrial material, sparking a rubber boom that brought both wealth and brutal exploitation to the Amazon region. Bamboo, though technically a type of grass, forms vast forest, like stands in many parts of the world's tropical and temperate rainforests. Its combination of strength, lightness, and rapid growth has made it one of the most versatile and sustainable building materials on the planet, used for everything from scaffolding and housing to furniture and paper production. These materials, one a liquid latex and the other a woody grass, are just 2 examples of the countless natural products that the rainforest has provided. resources that have been integral to the development of human societies around the globe. The defining characteristic that allows for such abundance, the single factor that unites all these diverse forest types, is water. Rainforests, by their very definition, are places of immense rainfall. The annual precipitation they receive ranges from a minimum of around 2,000 millimeters, or about 80 inches, to a staggering 11,000 millimeters, or over 430 inches. This constant and abundant supply of water is the engine that drives the entire system, fueling the rapid growth, the intense biological activity, and the incredible diversity that makes these ecosystems so unique and so vital to the health of our planet. The immense geographical footprint of the Amazon rainforest, a world unto itself, is not contained within the borders of a single nation. It is a continental phenomenon, a vast wilderness that sprawls across 9 different countries. While Brazil holds the lion's share, roughly 60% of the total area, the forest also extends into Peru, Colombia, Venezuela, Ecuador, Bolivia, Guyana, Suriname, and French Guiana. This transnational character of the Amazon presents both challenges and opportunities for conservation. On one hand, it requires a high degree of international cooperation to address threats like deforestation and illegal mining, which often span across porous borders. On the other hand, it means that a diverse array of governments and cultures have a vested interest in the forest's survival, creating a patchwork of different conservation strategies and protected areas that collectively contribute to the protection of the whole. The vast majority of this great forest, however, lies within Brazil, making this single nation the primary custodian of the largest and most biodiverse rainforest on Earth. The policies and priorities of the Brazilian government have a disproportionately large impact on the future of this global treasure, a reality that places a heavy weight of responsibility on its leaders and its people. The sheer antiquity of these ecosystems is a concept that is difficult to grasp in human terms. While civilizations have risen and fallen over a few thousand years, some rainforests have persisted in a recognizable form for at least 70 million years. This makes them the oldest living ecosystems on our planet, veritable living museums of biological history. They are the survivors of cataclysmic asteroid impacts, a series of ice ages that locked up the world's water in massive glaciers and dramatic shifts in continental positions. This incredible resilience, this unbroken lineage stretching back to the time of the last dinosaurs, is the key to understanding their unparalleled complexity. Over these vast stretches of deep time, the slow, patient process of evolution has had an uninterrupted opportunity to work its magic, building up layers of intricate relationships and fostering an explosion of specialized species. This long, stable history is the ultimate source of the rainforest's incredible biodiversity, a living legacy of an ancient and enduring world. This rich evolutionary history is perhaps most dazzlingly expressed in the rainforest's bird life. Many of the world's most beautiful and exotic birds are denizens of these dense tropical forests. The vibrant scarlets, blues, and yellows of a macaw's feathers, the comical and oversized bill of a toucan, the shimmering, iridescent plumage of a hummingbird. These are the living jewels of the canopy. Their bright colors serve a variety of purposes, from attracting mates to defending territories. And their specialized beaks and foraging behaviors are a testament to the incredible variety of food sources the forest provides. The air in the rainforest is a symphony of their calls, a constant and varied soundscape that is the very voice of the ecosystem itself. Life in the rainforest, however, is not just about the vibrant and the visible. The journey downwards from the sunlit canopy to the earth is a journey into a different world. The rainforest floor is a place of deep shade and high humidity, a world of perpetual twilight. It is often surprisingly open and easy to walk through, as the lack of light prevents the growth of a dense, jungle-like underbrush. The ground is covered in a thick, damp layer of decomposing leaves, twigs, and fallen fruits, a rich tapestry of decay that is the very foundation of the forest's nutrient cycle. In this world of muted light and earthy smells, survival often depends on sending a clear signal. The bright, almost fluorescent colors of many rainforest animals, particularly amphibians like the poison dart frog, are not a form of camouflage, but the exact opposite, a bold and unambiguous warning. These striking colors, a biological phenomenon known as aposematism, serve as a clear advertisement to potential predators that the animal is toxic and not worth the risk of an attack. A predator that survives an encounter with one of these brightly colored creatures will remember the experience and avoid that color pattern in the future. This evolutionary strategy has been so successful that some harmless species have evolved to mimic the colors of their poisonous cousins, borrowing their dangerous reputation to protect themselves. This intricate dance of warning, mimicry, and avoidance is a classic example of the complex, co-evolutionary relationships that define the rainforest ecosystem. The rainforest is also famously a world of monkeys, and these intelligent and agile primates are some of the most visible and charismatic inhabitants of the canopy. From the booming, territorial roars of howler monkeys, which can be heard for several kilometers through the dense forest, to the acrobatic, long-limbed grace of spider monkeys as they swing through the branches, primates have adapted to fill a wide variety of ecological roles. They are crucial seed dispersers, acting as the forest's gardeners by eating fruits in one area and depositing the seeds in another, helping to ensure the regeneration and genetic diversity of the trees. The incredible variety of monkey species found in the world's rainforests is a powerful indicator of the health and complexity of the ecosystem. Further contributing to the unique character of the rainforest fauna are the sloths, animals that have become famous for their incredibly slow and deliberate movements. This leisurely pace of life is a highly successful adaptation to a diet of leaves, which are low in energy and difficult to digest. By moving slowly and conserving energy, sloths have perfected a low metabolism lifestyle that allows them to thrive in the rainforest canopy. Their fur is often colonized by algae, which provides them with a greenish tint that serves as excellent camouflage amidst the leaves. And their entire biology is a masterclass in the art of doing as little as possible. The rainforest is also home to a vast and fascinating array of reptiles, creatures that often evoke a primal sense of fear and wonder. From the emerald tree, boa, a beautiful and perfectly camouflaged predator that lies in wait for its prey in the branches, to the poison dart frogs mentioned earlier, the reptile and amphibian. Communities of the rainforest are incredibly diverse. These cold-blooded animals thrive in the warm, humid conditions, and they have evolved an incredible range of adaptations, from the gliding flight of the paradise tree snake to the powerful constriction of the anaconda. They are a vital part of the food web, acting as both predators and prey, and their sensitivity to changes in temperature and humidity makes them important indicator species for the overall health of the ecosystem. At the very top of this intricate food web are the apex predators, the powerful hunters that shape the populations of the animals below them. In the rainforests of the Americas, this role is filled by the jaguar, a large and powerful cat with a beautifully spotted coat that provides excellent camouflage in the dappled light of the forest floor. In the rainforests of Africa and Asia, this role is filled by the equally elusive and powerful leopard. These big cats are masters of stealth and ambush, and their presence is a sign of a healthy and intact ecosystem, one that is large enough and rich enough to support a population of top predators. This incredible diversity of life is not randomly distributed throughout the forest. It is organized vertically into distinct layers, each with its own unique microclimate and its own specialized community of plants and animals. This vertical stratification is one of the defining characteristics of the rainforest ecosystem. Ecologists typically divide the rainforest into at least 4 main layers, creating a multi-story world where different species live out their lives at different heights. This structure allows for a far greater number of species to coexist in a given area than would be possible in a simpler, two-dimensional ecosystem, as it multiplies the number of available niches. It is, in essence, a biological skyscraper, with different communities living on each floor, all interconnected in a single, complex web of life. The very top of this skyscraper, the penthouse suite of the rainforest, is known as the emergent layer. The emergent layer is the highest stratum of the rainforest, a realm of giants that break through the main ceiling of the forest and soar towards the open sky. These colossal trees, some reaching heights of over 60 meters or nearly 200 feet, are the undisputed monarchs of the forest. Their broad, umbrella-shaped crowns are exposed to the full force of the tropical sun, the lashing rain, and the strong winds that sweep above the rest of the forest. Life in this exposed, high-altitude environment is challenging, characterized by fluctuating temperatures and dry conditions. The animals that inhabit this layer are typically those that can fly or glide, such as certain eagles, butterflies, and bats, who can easily travel between the isolated crowns of these giant trees. From this lofty perch, a harpy eagle, one of the world's most powerful birds of prey, can survey the vast green carpet of the canopy below, searching for the telltale movement of a sloth or a monkey that will be its next meal. The emergent layer is a world of immense scale and breathtaking views, a lonely and wind-swept frontier high above the forest floor. Just below this layer of giants lies the canopy, the true heart of the rainforest. This is the dense, interlocking ceiling of the forest, a continuous sea of leaves and branches that is home to the vast majority of the rainforest's biodiversity. Typically found between 30 and 45 meters, or about 100 to 150 feet above the ground, the canopy is a world of incredible biological activity. It is here that the trees, fueled by the abundant sunlight, produce the massive quantities of leaves, flowers, and fruits that form the base of the forest's food web. Life in the canopy is a three-dimensional affair, a world of aerial highways and arboreal neighborhoods. A bewildering array of animals have adapted to this elevated world, many of them never descending to the ground. Monkeys, sloths, toucans, snakes, frogs, and a staggering number of insect species all live out their entire lives in this leafy realm. The competition for resources is intense, and the evolutionary pressure has led to an incredible array of specializations, creating a complex and vibrant community that is the engine of the entire rainforest ecosystem. Descending further, we enter the understory, a world of deep shade and still, humid air. This layer, situated below the dense canopy and above the forest floor, receives only a tiny fraction of the sunlight that bathes the upper layers. The plants that grow here are specialists in low-light survival. They are often characterized by large leaves, an adaptation to maximize the capture of the scarce photons of light that filter down from above. The trees in this layer are shorter, and there is a profusion of shrubs and non-woody plants that can tolerate the dim conditions. The understory is home to its own unique community of animals, including many insects, frogs, and snakes, as well as larger predators like the jaguar, which uses the deep shadows and dense foliage as cover for its stealthy hunts. It is a quiet, watchful world, a place of subtle movements and intricate camouflage, a stark contrast to the bright, noisy, and active world of the canopy far above. At the very bottom of this vertical world lies the forest floor, the lowest and darkest level of the rainforest. As mentioned, it is often surprisingly clear of dense vegetation due to the extreme lack of sunlight. The ground is covered in a thick carpet of decaying organic matter, fallen leaves, branches, and other debris from the layers above. This is the domain of the decomposers, the vast and unseen army of fungi, bacteria, and invertebrates that are the forest's essential recycling crew. Larger animals that forage on the forest floor, such as tapirs, armadillos, and wild pigs, are often adapted to finding food by smell rather than by sight in this dimly lit environment. The forest floor is the foundation upon which the entire towering structure of the rainforest is built, the place where the cycle of life and death comes full circle, and where the nutrients that will fuel the growth of the emergent giants are painstakingly reassembled. In this vertically stratified world, where light and water are the most critical resources, rainforest plants have evolved a stunning array of unique adaptations to survive and thrive. One of the most common and elegant of these is the drip tip. Many rainforest leaves have a narrow, pointed tip that functions like a spout, allowing excess water from the frequent and heavy downpours to run off quickly. This adaptation is crucial for several reasons. It prevents the growth of algae and fungi on the leaf's surface, which could block sunlight and inhibit photosynthesis. It also helps to prevent the leaf from becoming too heavy and breaking its stem. The presence of drip tips is a simple yet effective solution to the challenge of living in one of the wettest environments on Earth, a subtle and beautiful example of natural engineering. Another common strategy for survival in the crowded and competitive world of the rainforest is to avoid the ground altogether. Epiphytes are plants that have evolved to grow on other plants, typically on the branches and trunks of trees. This strategy gives them a crucial advantage in the struggle for sunlight, allowing them to establish themselves high up in the bright canopy, far from the shadows of the forest floor. The rainforest canopy is a veritable garden of epiphytes, with orchids, bromeliads, ferns, and cacti all clinging to the limbs of their host trees. They are not parasites. They do not steal nutrients from the tree they live on. Instead, they have developed specialized roots that anchor them in place and absorb moisture and nutrients from the air and the rain, and from the decaying organic debris that accumulates around them. Among the most remarkable of these epiphytes are the bromeliads, a family of plants that includes the pineapple. Many bromeliad species have leaves that grow in a tight, overlapping rosette, forming a central cup or tank that collects and holds rainwater. These aerial ponds, some holding several liters of water, become miniature, self-contained ecosystems high up in the canopy. They provide a safe, predator-free nursery for the tadpoles of poison dart frogs, and a home for a wide variety of insect larvae, crabs, and even salamanders. A single large bromeliad can be a bustling metropolis of aquatic and semi-aquatic life, a tiny wetland suspended 100 feet in the air, a perfect illustration of the rainforest's ability to create life within life and complexity within complexity. The struggle to reach the sunlight has also given rise to another iconic group of rainforest plants, the lianas. These are woody vines that begin their life as small shrubs on the dark forest floor. They then use the trunks of established trees as a ladder, climbing upwards, sometimes for hundreds of feet, to reach the sun-drenched canopy. Once there, they spread their own leaves, competing with their host tree for light and resources. Lianas form a crucial part of the forest's architecture, creating a network of woody cables that connect the trees to one another. This can provide a pathway for arboreal animals to travel through the canopy, but it can also be a danger to the trees. When one tree falls, the lianas connecting it to its neighbors can pull them down as well, creating a domino effect that can open up large gaps in the forest canopy. The giants of the forest face their own unique set of challenges. A tall, slender tree is inherently unstable, and the often thin, shallow soils of the rainforest do not provide a very firm anchor. To solve this engineering problem, many of the tallest rainforest trees have evolved buttress roots. These are large, wide, flange-like roots that radiate out from the base of the trunk, sometimes for many meters. They act like the buttresses on a medieval cathedral, providing a broad and stable base of support that helps to keep the massive tree from toppling over in high winds or soft soil. These impressive, plank-like structures are a classic and easily recognizable feature of the tropical rainforest, a visible testament to the immense mechanical stresses that these towering trees must endure. In the constant battle against competitors, many rainforest trees have also evolved to have remarkably smooth, thin bark. This adaptation helps to prevent other plants, particularly epiphytes and climbing vines, from getting a foothold on their trunks. The smooth surface makes it difficult for seeds to germinate and for vines to grip, giving the tree a competitive advantage in the race to secure its own access to sunlight and space. The rainforest is far from a silent place. It is a world of constant sound, a vibrant and cacophonous orchestra of life. The air is thick with the calls of birds, a complex tapestry of whistles, squawks, and melodies that serve to attract mates, defend territories, and warn of approaching danger. From the deep, resonant roars of howler monkeys, a sound that can travel for several kilometers through the dense foliage, to the high-pitched chirping of countless insects and the croaking of frogs, the rainforest soundscape is a rich and dynamic expression of its incredible biodiversity. This constant chorus is the very pulse of the ecosystem, a testament to the sheer density and variety of the creatures that call it home. To listen to the rainforest is to hear the unfiltered voice of the natural world in its most exuberant and untamed form. This rich and vibrant world has been the home not just to a staggering variety of plants and animals, but also to a remarkable diversity of human cultures. Many indigenous communities have a deep and ancient connection to the rainforest, having lived in and from these ecosystems for millennia. Their relationship with the forest is not one of exploitation, but of intimate coexistence and profound spiritual connection. They have developed sophisticated systems of knowledge about the forest's plants and animals, understanding their medicinal properties, their nutritional value, and their role within the ecosystem. The rainforest is their home, their pharmacy, their supermarket, and their temple, all rolled into one. For these communities, the survival of the forest is inextricably linked to their own cultural and physical survival. The relentless destruction of the world's rainforests is therefore a tragedy on two fronts. It is not only an ecological crisis, driving countless species towards extinction, but it is also a human rights crisis, displacing indigenous communities from their ancestral lands and destroying their way of life. When the forest is cleared for logging, mining, or agriculture, these communities are often pushed aside, their land rights ignored, and their deep cultural knowledge disregarded. The loss of the rainforest is the loss of a vital part of our shared human heritage, the silencing of ancient voices, and the erasure of unique ways of seeing and understanding the world. Their struggle to protect their forest homes is a struggle for the preservation of both biological and cultural diversity. In the face of this overwhelming destruction, a new form of economic activity has emerged that seeks to offer a more sustainable alternative: ecotourism. The idea behind ecotourism is to provide a way for local communities to derive economic benefit from the preservation of their natural environment, rather than from its destruction. By attracting visitors who are willing to pay to experience the beauty and wonder of an intact rainforest, communities can create jobs and generate income from activities like guided nature walks, wildlife viewing, and lodging. When done responsibly, ecotourism can be a powerful tool for conservation, creating a direct financial incentive to protect the forest and providing a platform for cross-cultural exchange and environmental education. It can transform a standing forest from a potential source of timber or agricultural land into a living, sustainable economic asset. Alongside these economic incentives, there is a growing global movement to actively restore the rainforests that have been lost. Reforestation projects, ranging from small, community-led initiatives to large-scale, government-backed programs, are working to replant native trees in degraded and deforested areas. This is a slow and challenging process, as a replanted forest can take many decades, if not centuries, to regain the complexity and biodiversity of a primary old-growth forest. However, these projects are a vital source of hope, a tangible way of beginning to heal the wounds we have inflicted on the planet. They can help to reconnect fragmented habitats, restore vital ecosystem services like water filtration and soil stabilization, and absorb significant amounts of carbon dioxide from the atmosphere. As individuals living in a globally interconnected world, it can be easy to feel powerless in the face of such a massive and complex problem. However, our daily choices as consumers can have a real and measurable impact. Many of the products we buy, from the coffee we drink, to the paper we use, to the furniture in our homes, can be linked back to the world's forests. By actively choosing to purchase products from companies that are committed to sustainable sourcing, we can use our collective purchasing power to support responsible businesses and send a clear market signal that deforestation is unacceptable. This requires a greater degree of awareness and a willingness to ask questions about where our products come from. But it is a powerful way to vote with our wallets for a healthier planet. To help guide consumers in this process, a number of certification schemes have been developed. The Rainforest Alliance, for example, certifies products like coffee, chocolate, and bananas that are grown and harvested using methods that protect forests, conserve biodiversity, and support the livelihoods of local communities. When you see their green frog seal on a product, it is a sign that the item has met a rigorous set of environmental and social standards. By looking for and choosing certified products, we can help to build a global economy that values and protects the world's rainforests, rather than one that profits from their destruction. This is a practical, everyday action that can contribute to a much larger systemic change. Beyond our individual choices, the long-term future of the rainforests depends on the concerted efforts of governments and conservation organizations to establish and effectively manage protected areas. National parks, biological reserves, and indigenous territories are the cornerstones of global conservation strategy. These designated areas provide a safe haven for wildlife, a living laboratory for scientific research, and a protected reservoir of the planet's biological heritage. Many organizations are working tirelessly on the front lines of conservation, fighting to establish new protected areas, to strengthen the management of existing ones, and to combat the illegal activities that threaten them. The success of these efforts is crucial to safeguarding the last remaining strongholds of rainforest biodiversity for future generations. Ultimately, the future of the world's rainforests will not be decided by any single solution, but by a combination of many different approaches. It will require a global commitment to conservation, a shift towards more sustainable models of development, and a renewed sense of cooperation between nations, corporations, and communities. It will involve everything from international climate agreements and the enforcement of environmental laws to the empowerment of indigenous communities and the conscious choices of individual consumers. The challenge is immense, but the stakes could not be higher. The fate of these vibrant, life-giving ecosystems is a reflection of our own values and our willingness to act as responsible stewards of our planetary home. By learning more about the rainforests and the profound threats they face, we can all become more effective advocates for their protection. The journey from ignorance to awareness is the first and most crucial step. These ecosystems, despite being some of the most diverse and important on Earth, are also some of the most threatened. Their fragility is a stark reminder of the immense power that our species now wields over the natural world. Whether we use that power to destroy or to protect will be the defining story of our time. The choice is ours, and the future of the rainforests, and indeed the future of a healthy planet, hangs in the balance. And so our journey through this world of green comes to a close. We have traveled from the sun-drenched crowns of the emergent giants to the deep, eternal twilight of the forest floor. We have discovered a world of almost incomprehensible vitality, yet one of profound and heartbreaking fragility. The story of the rainforest is a story of connection, of the intricate dance between fungi and root, between flower and pollinator, between the canopy and the clouds. It is a story written in the language of evolution over 70 million years, a living memory of our planet's deep past. Though these forests may seem distant, their presence is woven into the fabric of our own lives. Their influence is in the oxygen that fills our lungs, the medicines that heal our bodies, the steady rhythm of the rain that falls on our own homes. They are not a separate world, but a vital organ of the single living planet we all share. To listen to the echo of the howler monkey is to hear a voice from an ancient world, a world that now depends on a modern one for its survival. As we leave the shade of these great trees, we carry with us the understanding that their future and ours are not two separate stories, but one and the same. And in the quiet moments, we can still hear it. Not the clamor of its destruction, but the steady, quiet hum of its persistence, a soft and hopeful breath in the deep silence of the night.